Welcome to the InfoQ Podcast. My name is Wes Reisz, and I'm your host. The InfoQ Podcast is a weekly chat with software leaders around topics of interest to senior devs, architects, and technical engineering managers. These podcasts are snapshots of the types of knowledge and conversations you can gain online at InfoQ.com and in person at the QCon software conferences that I chair. The next QCon is in March in London, 2018. Look forward to seeing you there. Today's podcast is with Chris Swan. Chris is the CTO for the global delivery organization at DXC Technology. He's a longtime friend of QCon and a cloud editor at InfoQ. Chris is well-versed and known in the space of operations, DevOps, infrastructure, culture, and as you'll see today, what it means when you put all these things together. Today, some of the topics that we hit on include defining DevOps, NoOps, and what Chris calls LessOps, what operation means in the world of serverless, where he sees configuration management, provisioning, monitoring, and logging heading, then wraps on his thoughts on validating code in a serverless environment, things like canaries, blue-green deployments in the serverless world. Thanks again for joining us on the InfoQ Podcast. Chris, welcome to the InfoQ Podcast.
Thanks, Wes. Pleasure to join you.
So we now officially have some shared commonality.
Yeah, it's kind of cousins from different families or something.
Yeah. So before I joined the QCon organization, I was at HP Enterprise and Chris was at CSC, and now they're one company.
Well, kind of. So HP Enterprise did this three-way split last year. So the servers and storage business continues under the HP Enterprise banner. The enterprise services business joined CSC to be merged into DXC Technology, which is where I am. And then lastly, the software business was spun merged into Micro Focus.
Did I hear that there's another merger in the offing?
There's actually another spin merge going on. So similar to what CSC did with the spin out of the federal business to CSRA, we're doing a similar transaction, which is going to be the US public sector part of what was in ES, is being merged into another entity in that space to create a new company.
Well, let's jump into this. Your LinkedIn bio says you're an IT mixologist, cloud gazer, and security guy. Well, I love the phraseology of IT mixologist. What does that mean?
So many years ago, I had a colleague who was doing a mixology class in New York City. And so I spent a bit of time talking to him about the skills of a mixologist making cocktails. And so, a mixologist, it's all about understanding your ingredients and understanding what works together. And I think it's just the same for an IT mixologist. It's about understanding what's out there in the landscape and then which bits you can put together so that they're still going to taste great.
This podcast came from reading a bit about a conversation. It was a post, but a conversation you had that was around the defining of DevOps, NoOps. So what I thought we'd talk a bit about is this conversation. So what was the genesis of this article, this blog post?
The genesis of this came from a conversation with Paul Johnston. And he's now at AWS, but he was previously a CTO of a London-based startup called Movio, and they built out their entire serverless functions on Lambda. And I don't think he even realized it at the time that he was one of the first people really doing this in earnest. But he was starting to hit some blockers around testability and things that he was trying to do in his release cycle. And that kind of raised the question of how would you do canary testing in a serverless environment? And at the time we were talking about this, there really wasn't an elegant way of dealing with that. Now, there's some changes have been announced to Lambda around traffic shifting, which are going to enable blue-green deployments and canary testing, which is great. But it's sort of illustrative of the fact that there's all of these practices that we developed around infrastructure as a service, and they've become well understood and well adopted. And then we get new technologies come along like serverless. And there's a new set of practices co-evolving around them, but occasionally they throw the baby out with the bathwater, and you end up with stuff that kind of should be there, but it's certainly not there in V1.
In this particular article, you talk about NoOps. Is that even a thing? I mean, it basically connotates that ops is dying. It's simply not important, right?
There's certainly a bunch of people out there that think NoOps can be a thing. This idea that all you do is write your code and you throw it onto some kind of magical platform, and from there on, it takes care of itself. And I think at the present point in time, this turns out to be just a fantasy. And so there's a whole bunch of stuff that you're still responsible for in terms of user expectations of your application or your service that become about the operations and the operational culture that your organization has behind that. And so just because we no longer have servers in a serverless environment doesn't mean that all of the operations went away. So all of the operations that we had anyway that were nothing to do with the actual servers themselves are still there. What seems to be kind of crystallizing in the serverless environment is you can look at this sort of purely from a lines of code perspective, that you've got lines of functional code that are actually the functions running on your serverless platform. And then you've got lines of configuration, let's call it configuration code for the sake of argument, which is setting up your API gateways and setting up your security groups and
access permissions.
Yeah, there's just a ton of stuff. So Gareth Rushgrove, Puppet, had done a little bit of digging around and scraped together some metrics here. And it's looking like it's roughly a 3-to-1 ratio. 3 lines of config for every 1 line of actual code.
I saw a great quote, something, I don't know I think it was from Gareth that you quoted, but it was, you could knock something together in a few lines of Python, but then write hundreds of lines of configuration management to actually get it to do what it was supposed to do in the first place.
Yeah. Yeah, I just read something in the last few hours which sort of said, I don't see what the fuss is about serverless, it's just glue. But it's space-filling glue, and I think we're seeing examples of where you can make an entire thing out of nothing but space-filling glue, or the sort of software equivalent of glue and string and chewing gum can give you an entire application stack. And you might be making various trade-offs to accomplish that, but what you might get in return for that is the ability to scale without some of the limitations that we've had in place in the past.
Yeah, it's super powerful. You can open up something like Juniper Notebooks, be able to write some Python code against Redshift or something, and then be able to take that, deploy it with serverless, and it's hugely scalable. It's incredibly powerful.
Certainly is, and I think that's the promise to everybody that's interested in this kind of technology, that you can start small and grow big without too many constraints around the team and the scale of the software engineering and the operations department that you might have to build behind that.
You mentioned operations. Let's talk specifically about that. Before we jump into some specifics, let's just define what is operations in the context of serverless.
Let's actually step back from the context of serverless, because I think this is sort of more broadly germane. And I like the Charity Major's sort of definition of this, of operations as the constellation of your organizational technical skills, practices, and cultural values around designing, building, and maintaining systems, shipping software, and solving problems with technology. And that's very broad and sweeping. And it kind of says operations is that set of cultural artifacts that do all of the things besides writing software that makes your application or service a real thing that human beings can come along and make use of. Now, from a more technical perspective, I tend to be somewhat reductive in talking about this. So I normally look at the activities that we participate in operations. And so we do provisioning. We get software to where we want it to run, and we do config management. We set things up so that it runs in the right way. And then we do monitoring. We make sure that the thing we're running is running in the way that we expect it to. And as we move to a more microservices world, then arguably we're moving away from traditional monitoring and moving towards more of an observability paradigm. And then we have logging. So our application and the infrastructure of whatever kind that we put around it is generating log events. And there's normally some need to keep that for audit trails and forensic reasons, but also to be able to do diagnostics on that. We can take all of these reductive things and kind of say, will we carry on doing those as a new paradigm comes along? And so, whether that's virtualization, as we've seen in the past, whether that's containers, which feels like the hotness at the moment, or whether that's serverless, which feels more like the coming thing. And we can say, are we still going to do provisioning? Well, yes, we are. If you look at how something like Lambda works, then you take your JavaScript function and you perhaps bundle it up with a bunch of dependencies, and you need to copy it into an S3 bucket and point your environment at that bucket. So you've done some provisioning. Do you have to do configuration? Well, absolutely. As we just touched upon, you've got API gateways, you've got security roles, you've got access policies. So all of that stuff needs to be done. Are we still doing monitoring? Well, yeah, there's monitoring is a little bit more built into the platform than it was before, and the same can be said for logging. If we kind of push against this a little bit harder, then you can start to see that all of these things, because they're presented as a service, become configurable. So you can say, well, actually, I'm not necessarily having to do provisioning anymore, because I can just configure a means of provisioning. So I can take a provisioning engine and configure it. I don't have to do monitoring anymore. I just configure a monitoring service, and the same can possibly be said for logging. So when you kind of squeeze at that end, it starts to become, well, everything's configuration management.
Configuration as code.
If you view this as infrastructure as code, then you've just got code. So this perhaps brings you back to NoOps, because you can say, all I've got is my code. But then when you look at that code base, if Gareth's numbers are representative, then 3/4 of your code base is actually operations configuration stuff, not functional code.
You talked about paradigms. I think that's an interesting comment that was also in this post. When we started with DevOps, there was certain paradigm shifts, and that's kind of indicating that we may have a similar paradigm shift perhaps with serverless, right? So let's back up. What were the paradigm shifts that we saw as we moved into kind of a DevOps mindset?
So I'll kind of refer to two of the great sort of visionaries of our industry here, and point out a conflict in what they have to say about this. So if I ask Simon Wardley about this, then he says stuff evolves from its genesis through normally a product phase and eventually to a utility phase, and operational practices co-evolve with those things. So virtualization first happened with mainframes decades ago, and then we got VMware and virtualization in the more generic x86 compute environment. So we had virtualization as a product, and then along came Amazon and made virtualization as a service. And they weren't unique in doing that, but they were very successful in doing that. So we've now got virtualization as a service, and operational practice co-evolved with that. And the name we ended up giving it was DevOps. And I think all of that is entirely true. But I'll kind of state the exception that if I take the Gene Kim view of DevOps, then DevOps is about the 3 ways of DevOps borrowed from manufacturing of flow, feedback, and continuous learning by experimentation. So if I'm sort of Wardley-esque about how I see this, then when a new paradigm comes along, and containers actually isn't that different from virtualization, so it doesn't necessarily bring a huge shift in operational practices, though something like Kubernetes orchestrating containers actually rather more so does. But serverless is definitely a new paradigm, and so we can expect to see the growth of new operational practices, and I think that's emerging in front of our eyes. Whereas the flow, feedback, and continuous learning by experimentation, I think, stays relevant throughout those paradigms. It's sort of relevant in manufacturing, and it's been relevant as we've seen the adoption of infrastructure as a service, which is sort of when software people woke up to everything that had been learnt in manufacturing. And I think it's still going to be equally relevant with serverless. So it's then just a question of labels. And as we spend our time in this industry arguing over labels all the time, serverless is a stupid label because there's still servers. And people are still having the argument about what the DevOps label means. And so maybe it will be kind of consigned to drift backwards in time with infrastructure as a service as that becomes less relevant. Or maybe if people stick to those kind of 3 ways of DevOps, of the flow, feedback, and continuous learning by experimentation, then it just gets repurposed as each new paradigm comes along.
So in that last step, it talks about continuous learning through experimentation. You mentioned canaries earlier. In a serverless environment, what are some of the current limitations that people have to think about if they're using a serverless environment?
Let's first of all just kind of recap on what we're talking about when we say blue-green deployment and canaries. And both of these have got excellent explanatory blog posts on the ThoughtWorks blog. So I would point people in that direction as a sort of canonical view on what these techniques are. Blue-green deployment is the idea that you've got two versions of your code and that you can have a sort of swing of traffic from one to the other. And canarying, my take on it at least, is it's just a much more discretely controlled version of that, where you can put a finite proportion of the traffic to your newer version and pay close attention to the monitoring and how that's going. And if everything looks like it's going okay, you ramp more traffic over to the new version. And if something looks like it's going awry, then you can dial that back.
And that ties into the observability that you were talking about. So you can measure the canary versus what your existing architecture or your existing system looks like and be able to make sure there's not a delta, that type of thing, right?
Absolutely. And you can also be quite focused about this. So if you know where your traffic's originating from, especially in terms of user identity and role, then you can say something like, the early traffic will only actually be to insiders or friends and family who are going to be relatively soft targets or relatively happy to have a less than usual experience if that turns out to be the case.
Right. Like Facebook's really common about doing this. They'll deploy it to their own internal folks before everybody else starts to see it.
Yeah. And we've seen great case studies on this from Netflix as well. So I recall Roy Rappaport doing an excellent presentation on this a few years back at QCon New York. And so canarying has become an established part of how state-of-the-art organizations do robust deployments in an infrastructure as a service world. And if you look at an organization like Netflix, they've been able to reasonably straightforwardly drop containers in the place of VMs and keep on doing canarying. So the move from VM to containers didn't really impact that operational practice. But when we then look at serverless, where's the load balancer? Well, there is still a load balancer there, but it's behind the magic curtain. And until some sort of relatively recent announcements from Amazon, there was no way of controlling that. So Amazon has now said that they're going to allow traffic shifting in Lambda functions, which will then facilitate blue-green deployments and canarying. But here's a fairly robust, mature, and well-understood set of operational practices that have become de rigueur in sophisticated infrastructure as a service-based organizations. And along comes serverless, and it just wasn't able to support that.
So I'm not familiar with the announcement by AWS to be able to support traffic shifting inside Lambdas. What is actually inside the Lambda itself? You're going to be able to shift traffic or at the API gateway?
So what it's actually doing is giving you control over their internal load balancer so that as you release a new version of the Lambda function, you can determine how the traffic is directed between old and new.
And you can do a subset of users or use some type of criteria to be able to only make it available to friends and family?
So the details of that aren't actually clear yet. So this is a feature that's been announced, but last time I checked, hadn't actually been made available. So I've not seen any documentation explaining how exactly it's going to work. But I think if it follows the characteristic course for many of these things, it'll probably start out as quite a blunt instrument that you'll be able to put a metric onto one leg or the other, and it'll gain sophistication over time to accommodate the kind of use cases we're talking about here with things like role-based routing.
So we talked about canaries and blue-green deployments. What are some of the other cultural shifts that are occurring as people move into more of a serverless environment?
Yeah, I'll take my preferred definition of culture here as the way we do things around here. And serverless is causing organizations to change the way they do things. And so it's causing those same organizations to change their culture. If I go back probably a year and a half now, I always get along to the AWS Summit in London. And what intrigued me, this is a year and a half ago, so summer of 2016, they had two case studies which were for companies that had essentially the same product. And one of those was Monzo. So you've got prepaid debit card optimized for spending in foreign exchange transactions. And they were there actually to talk about the financial conduct authorities sort of happy with a startup tech company using AWS to run its business on. But the architecture for what they were doing wasn't really the topic. And then you had TravelX, and they were there as the case study for Serverless and Lambda, because they'd released an almost identical product, a prepaid debit card that was optimized for cheap FX transactions. And they'd needed some space-filling glue between a bunch of systems that they were running internally and a bunch of external vendor services that they were connecting into. And so in this case, the case study was that they'd been able to get a team of just, I think it was 3 people, and throw together some functions that achieved what they needed to do and deliver this thing really quickly and astonishingly cheaply. And so the metrics around the speed to market were super impressive, but also what they were spending on their Amazon bill in order to actually run this thing was, it was moving the decimal a number of times. And I think I tend towards a definition of disruptive, which is if you can move a decimal, then that's probably going to be disruptive to the existing environment. And so they'd moved the decimal not just once on this thing, which was obviously going to have consequences. And that had changed the culture of a small part of that organization, but you could then kind of see them sort of almost salivating over the speed to market and cost efficiency advantages that they'd been able to achieve and saying, well, what else can we do with this?
So what are some of those that you're seeing with serverless in particular?
Well, I think the other part to this is it's very early in the adoption curve. And so there's going to be things like that, which are just slam dunks. But there's going to be an awful lot of stuff that actually doesn't fit. And what we have to remember here is the mainframes haven't gone away. The AS400s and the VAXs and all of that stuff hasn't gone away. So we end up with these onion architectures. And serverless right now is just the thinnest of skins starting to form at the very outside edge of our onion. So it's going to consume a whole bunch of the applications that it's an easy fit for very, very quickly. But then the next phase in this, I think, is going to be accelerated by the function libraries that we're starting to see emerge as marketplaces, because the best code is the stuff you don't write at all, where there's something already there that just works. And so what we'll then see happening from an organizational perspective is not necessarily adoption of serverless in the context of the traditional software development and operations organizations that they have, but problems being already solved that they can just connect into.
So you just mentioned function libraries. I'm assuming you're talking about things like the serverless framework. What are you seeing as far as adoption with some of these libraries?
So actually, I wasn't referring to the serverless framework, but it's worth just briefly touching on the fact that those things exist and why they're there. So there's a bunch of frameworks, and the serverless framework's an excellent example of them, that have emerged to make getting started with serverless as pain-free as possible. And actually, they're interesting because a lot of what they're doing is that ops grunt work. So they're turning code into more efficient ops outputs than you'd have necessarily got if you were kind of yak shaving this stuff together for yourself as a bunch of YAML files. And actually, I see the same sort of set of behavioral practices going on in the Kubernetes world at the moment, that Kubernetes is driven by this kind of menagerie of YAML files, and just pointing kubectl at a YAML file can achieve incredible things, because it'll stand up a whole bunch of pods for you that will do your monitoring or whatever else. And so we've got all of these components now being shrink wrapped, and then once you've got the components shrink wrapped, you can start to just simply assemble them or poke inside and modify the little bit that you need. And so things like samples and examples of old, if we look back to the days of WebLogic and Java Enterprise Edition, we had the Java Pet Store which was the sort of canonical example. But I saw much more being built out of the WebLogic samples and examples. If I look now at something like, Weaveworks did the sock shop as the modern day pet store, then it's sort of the best of both worlds, because it's no longer a monolith. It's made out of all of these little bits that you can just go into and customize. And if history repeats itself, it often does, I'd expect to see a lot of applications are just taking boilerplate like that and modifying in order to then become relevant to whatever particular problem they're being applied to. What I really meant when I was talking about the function libraries was less things like the serverless framework and more marketplaces for functional code that actually does something. And so if I think about contemporary example, it might be a piece of functional code that's able to add things to the blockchain. And why write that from scratch yourself if you can go along and just get it per invocation out of a marketplace?
Let's go back to the serverless library, for example. What is it giving you? I mean, we just mentioned earlier, because we kicked off, that you can write 30 lines of Python. That's the code. And then you deploy that out into Lambda, something like that. And then you've got to configure your API gateway. You've got to figure your security permissions around it. You've got to configure the ACLs and how you're going to access different things. Where does the library like the serverless framework fit in to helping you take that 30 lines of Python code and getting that into an environment on AWS Lambda that you can then call quickly?
So I think a lot of this comes down to the question of boilerplate, and probably makes for an interesting segue into the topic of metaprogramming. But the 30 lines of JavaScript or Python code or Go now or whatever else you want to actually write your function in is still going to have to be written. But the problem that these frameworks are solving is, how do you take care of all of the things that you would need to do from an operations perspective to get them out there? And a lot of it is boilerplate. And so a lot of it can actually be boilerplate in the framework that you just fill in the gaps, essentially.
I see. Okay, so it'll go out there and it will create the role that you need, and then you can then use that role to be able to execute your Lambda. And I mentioned Redshift before, if you're accessing Redshift, it can create the access between Lambda and Redshift so that you can be able to make the connection with as little friction as possible. Something like that.
Yeah. And an evolution that I've seen subsequently is you start to connect this into a development environment and a CI/CD pipeline. So one of the services that AWS has that I'm surprised they're not screaming about more is a thing called CodeStar. And somebody recently gave me a demo of this, and it'll take you all the way from their Cloud9 IDE to deploying the function out into Lambda, and it'll run tests for you and all of that stuff along the way. And the whole thing is just turnkey. So you can start out with Hello World, and it'll deploy Hello World web app for you. And you can then live edit what the changes are that you want to make to Hello World and press the deploy button, and off it goes. And it's a bit slower than you might think it ought to be, but it's still super impressive.
A little earlier, you defined disruptive as moving the decimal point. So as we just turned over to the new year, what do you see as the things that have the potential to move the decimal point coming up in 2018?
So I think we're going to see a lot more of machine learning and artificial intelligence. And what we've seen over the course of the last maybe 2 years has been the quality of the inferences that we could make in machine learning went from pretty bad, and so it was all just a bit sloppy and we weren't able to trust it, to now actually really sharp. So we can make really sharp inferences that have got low false positive rate, low false negative rates, and they're starting to become dependable. And then if I kind of draw a line between ML and AI, then ML is the ability to make the inferences, and AI is the ability to make decisions based upon those inferences. And so the outcome of this for me is we're suddenly getting to software that doesn't suck. And software generally sucked because it asked you questions that you thought it should already know the answer to. And we're now starting to get software that doesn't suck because actually the developer can kind of go, right, I do know the answer to that. I can infer that at a high enough accuracy that I can take a guess at the answer that's going to be good enough that most cases the user is going to go, yeah, that's exactly what I meant. That's exactly what I wanted to happen. And so I think as an industry, we've started to see the early fruits of that, but we've got so much more to work through in order to have software that doesn't suck. So the rolling progress of ML frameworks and the AI that we build upon them through our industry is going to be a huge factor for this year and years to come.
I couldn't agree more. What do you think is driving the surge of AI and ML right now?
Well, one part of it has to be the huge investment that's being made from the hyperscale operators. And there I look to Google, Facebook, to a certain degree, Apple, and we shouldn't ignore the Chinese operations. So, Baidu, etc., Alibaba, they're all making huge investments in this area. And there's some fascinating stuff coming out of it. So there was a paper came from Google just a few weeks ago where essentially they're saying they can use machine learning to build application-specific indexing mechanisms that will become more efficient than the B trees that we might have used in the past. And so I think there's a whole bunch of problem spaces that we've previously encountered where we've used relatively blunt but general purpose tools to solve against them. And what ML is doing us is the ability to have a custom fit tool for each of those application spaces. And that tool is very sharp to the job it's being put to. One of the observations I could make about ML is it's allowing people to try out all kinds of mathematical techniques that had previously been domain specific to an alien domain. So not the domain that they're necessarily dealing with their application.
So like a Java developer using AI ML.
Like a Java developer being able to, rather than doing a 50% badly implemented part of Lisp or whatever the joke is, just being able to drop Lisp in and have it work. So what's happening here is there's all sorts of mathematical techniques that are well understood in a particular domain, but have not been attempted to be applied elsewhere, are now basically being packaged up as ML approaches and then kind of shotgun tested against a problem space. And we're finding that, hey, that math that we came up with for so-and-so turns out to be really useful for such and such. Who knew? And in the past, nobody knew because those mathematicians and those domain experts weren't ever going to the same conferences together.
History's replete with these examples of where we apply some techniques from one domain into another and find out, it works fantastic there.
The thing that got me wondering about it was tensors. When I first looked at tensors and kind of thought about what I'd done in avionics and learning about classical control theory, I was asking myself, so why don't we use tensors for avionics? And I've still not got a clear answer on that. But what we certainly are seeing is, and again, there's sort of marketplaces for this with things like Kaggle. People are just automating the trying out of lots of different algorithmic approaches and finding the one that best fits their piece of data or their particular application space. The old joke about software engineers is kind of, theorists know how things should work and practitioners know how things do work. And software engineers don't know how things work and don't know why. And I think actually what a lot of these tools are giving us the ability to do is have all sorts of new ways of not understanding why things are working. And that toes into all sorts of ethical concerns. And if we look at things like GDPR as well, it gives us problems in terms of explaining how we arrived at an answer, which we're going to have to reconcile. But I think mostly this is a net good thing.
There was a talk at QCon San Francisco, it was keynote Leslie Miley, that was about ethical consideration and inherent bias in data sets, and basically was challenging us that as we start adopting more AI and ML, that we need to understand the ramifications of the tools that we're developing.
Well, in natural language processing, so I think there's a whole lot of inherent bias in language. And so as soon as we use any human language to express something, we're carrying that bias with us.
Well, Chris, thanks for taking the time to chat with us on the InfoQ podcast.
Always good to catch up with.